Surabaya, as the second largest city in Indonesia, serves an important role in international trading, having one of the biggest ports in Indonesia. The fast development of Surabaya at the same time fosters quality education throughout the city, and it has several major universities, and one of them is Institut Teknologi 10 November. Currently, this campus undergoes a development plan to scale up its student outreach. It is changing from Institut Teknologi 10 November to ITS University. Arapaima's team objective is to design a futuristic sustainable complex to accommodate this plan, while also creating solutions around the problem the area currently faced. These are the problems that we found near the area, and we try to create a sustainable and green energy system for our complex, reduce our carbon emissions, and increase the local economy by using local materials such as bamboo as our main facade material. We also approach our structural design to be built using cross-laminated timber, a zero-carbon material, while keeping the structural integrity of every building, and we design our complex to be pedestrian-centric, providing safety for every entity inside while reducing our contribution to air pollution. We start our site analysis using climate consultant and weather spark to get a preview towards site precipitation, temperature, microclimate, and wind analysis. Then we decide our site location inside our existing campus, which had a wide empty area that can be utilized. It is also near the main city road and a bamboo forest. This is our chosen location, and it is right besides the main campus connectivity. And we present Pringdarya Edu Complex of ITS University. In Sanskrit, Pring means bamboo and Darya means grow. Together, it creates a growing bamboo, a symbolization for education that has a great foundation and keeps growing. We approach our design using three main functions. Educational function, which provides an inclusive and safe environment for students to learn. Social economy function, which provides macro and micro-urban spaces for social interaction, collaboration, and recreation, while also empowering the surrounding community to provide an SME platform. Ecology function, which provides a biophilic and energy-efficient design by implementing the use of sustainable material and a passive design approach. We started our mass study by reducing shape, creating entrance, human access, and air circulation. Then, we maximize urban space on building space and green rooftop to reduce heat island. This strategy provides a stack effect between buildings and creates shades which can be used for outdoor collaborative space. We also analyze the microclimate, sun hours, wind comfort, wind direction, and daylight potential around our site to provide optimal comfort for everyone around the building. We use passive design strategies in Pringdarya Edu Complex as our commitment to create a sustainable and comfortable future environment while reducing our energy consumption. We introduced smart mobility system by implementing a smart campus navigation system, and we maximized the use of bicycles, electric scooters, and iCar or electric car. For daylighting strategy, we optimized natural ventilation by large openings in every building and utilized a smart lighting system by using sensors and data. We also use solar street lamps to reduce electricity consumption during the night. For water efficiency, we implement rainwater and ablation catchment, retaining lake, bioswale, and water treatment plant system for which can collect, recycle, and redistribute water into the lavatory, garden, and other water usage around the complex. In Pring Darya Edu Complex, we use the pneumatic waste system. The chute connects to an underground pipe that leads directly to a central waste handling facility. Once full, they are transported by trucks for final disposal. We maximize our massing to create stack effects between building, and our building design depends on cross ventilation. For our active ventilation strategy, we use an HVAC sterilization unit which includes a filter to remove bacterial and viruses. Our green rooftop and vegetation around the complex provide heat island reduction and create thermal comfort. In order to reduce our carbon footprint, we designed our main building structures to use cross-laminated timber and glulam. We also use green concrete, which use material from previous demolition, fly ashes, and plastic waste. Our facade design using bamboo also serves as a passive cooling system that can absorb and scatter heat from the sun whilst letting air circulate around it. These bamboos are easily obtained near the site. With a high number of pedestrian traffic, we utilize piezoelectric in the form of PEFGEN tiles to convert footsteps into electricity. Then we use solar PV panels on buildings to generate sustainable energy. And to provide safety for everyone, we implement a wireless sensor network system which automates the security measures. We also install SHMS or Structure Health Monitoring System in our buildings in case of an earthquake in the area, so we can monitor and analyze the structural integrity of the building. We also analyzed the comfort and energy used in the Pring Darya complex. We were using Dilux to analyze interior daylighting, and the result was satisfactory with a lux range of 300 to 3000, which is good for day-to-day activity. Then we analyzed solar energy in the Pring Alit building, and we achieved 35% energy from solar, and in Pring Pidari building we achieved 88% energy from solar. We also used the solar chart to simulate solar position and shadow projection. These are the software and tools we used to complete our design. For a team of 5, we divide our jobs as follows. And this is our timeline to complete the project and several challenges we faced while doing the task. Thank you for listening us until the end, and Team Arapaima would say, terima kasih.